Okay, hi everyone, I guess we can begin. Thank you all for coming to the session. I'm happy to see you all. My name is Alina, and I'm here to talk with you about GraalVM and Spring Boot and how they are even more amazing together. Let's go. And let's start with a little bit of intro. So this is my name, this is my handle on Twitter and basically any kind of social media. So if you want to ask a question, follow up, ask for demos, etc., you can find me by this name and this handle. And I'm a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle, where we are creating brand new technologies, bleeding edge, doing a lot of research. This unit originated originally from Sun Microsystems, so back from those times. So I'm very happy to be working in this part of Oracle. And I love open source and communities. That's why I love coming to conferences like this, where I get to talk to people in person. And I love both programming and natural languages. So if you would like a brief lesson into Swiss German, you can catch me during the break. Or if you want to teach me more of normal German, you can also do it during the break. And this is my photo. So again, you can find me on all kinds of social media by this photo and my name. So let's talk about GraalVM. And the first thing about GraalVM is it's a big project. There are a lot of parts to it. So sometimes people are confused about what it is and what it is not. So in the end, GraalVM is just a JDK, like any other JDK of your choice. So Oracle JDK, OpenJDK, etc. And we just add things on top of the JDK. We don't basically remove any parts of it. So anything that you can do with any other JDK, you can also do with GraalVM. And we add things on top. One such thing is the GraalJet compiler. So we have our own highly optimizing top-tier compiler. Like in OpenJDK, you would have C2 as your high-level compiler, and we have our own GraalJet compiler. A fun fact, it is itself written in Java. So we develop our compiler in Java, and then we compile it with native image. So in the end, you have a small and very fast native executable. So another part that we add on top of normal JDK is this truffle API and framework, which lets you implement additional languages on top of GraalVM. So we have our own implementations. You can run JavaScript on GraalVM, you can run Python, and there are even fun community implementations because it's fairly easy to implement a new language on GraalVM. You just develop an interpreter for your language in Java. So we see community projects such as PHP on GraalVM and C# on GraalVM and so on. And the last but not least part of GraalVM and the topic of today's session is native image. And that is this ahead-of-time compilation part of GraalVM, where you can take your Java program and compile it ahead of time into a native executable that no longer requires the JVM to run. And this will be the topic of our session today. OK, let me switch. So this is basically the choice that you have with GraalVM, and that's what makes GraalVM stand out comparing to any other JDK. And that is that with GraalVM, you get this choice where you can run your application on GraalVM as a JDK, just with your Java command. And migration there is very easy. You just swap your installation for GraalVM, and you run your applications on GraalVM as on any other JDK. And what makes GraalVM stand out comparing to other JDKs is this native image part, where first you build your application as a native executable, and then you can run it just as a native program very fast with no additional overhead at all. And I like showing this slide because A, it's a beautiful slide, so I'm very proud of our team's design skills, but also I'm proud of the work that we did along all those years. So as I said, we do a lot of research, and GraalVM has been such a research project for over 10 years. When in 2011, my project lead, Thomas Würtinger, joined Oracle and started working on GraalVM. And then we've been doing almost a decade of research to make it happen. And a few things that I would like to highlight here is that we went with our first GA builds in 2019. So it might seem like GraalVM is a very new project, but really it has been around for a while. And the next important milestone that I would like to highlight here is that in 2020, so 4 years ago, Alibaba already went with GraalVM native image in production under a huge load. So I can see how GraalVM can seem like this, groundbreaking, new, revolutionary project, and it definitely is. I can see that. But also there are people and teams who have been using it in production under a huge load, because Alibaba, you can imagine, right? And they've been very happy about performance, resources usage, all kinds of metrics ever since 2020. And getting closer to the topic of today's session, 2 more important milestones. So in 2021, the Sprint team released Sprint Native as a beta release. So you could have built experimental projects with GraalVM and Spring Boot even in 2021. And then we went to GA with this integration in 2022. So now GraalVM and native image are readily available out of the box for Sprint projects, and you can totally use them in production for your own projects. So let's talk about native image and important things to keep in mind when you want to compile your Java applications to native. So you might think, how is it even possible to take something as dynamic as a Java application and compile ahead of time to a native executable? Because it seems like there are a lot of things that are happening at runtime. So the way native image works is that when you run a native image command and give it your application in the format of bytecode, so it has to be classes or a jar, what will happen is that native image will look at your application, starting from its main entry point, and it will try to find all the reachable code. So all the code that your application is actually using, and that applies to your what we call user code, so the code that you actually wrote, but the same applies also to all of your dependencies and even the JDK classes that you are using. So it will try to explore and find everything that you're actually using, and then only put that things, classes, methods, fields that you're actually using in that native executable and eliminate everything else. Because we want to produce a readily available version of your application, and we don't need to compile it anymore at runtime, unlike the JVM. So all this happens at build time. So we will eliminate everything else, everything that you don't actually need and don't use, and in the end, we will have a small native executable. So that is one part of the story, and often people call native image an ahead-of-time compiler, but that is not the full story. So another interesting thing that native image is doing, it's looking at your classes and your application code, and it's trying to pre-populate heap. So populate your heap with objects and take a snapshot, so then you can start with a pre-populated version of your heap much faster. And that is all to eliminate this overhead of what you can see often for bigger Java programs when you first run them, and that is a bit of this warm-up curve where you need to load your classes, the JVM needs to analyze your application, understand what is happening, which part of applications are hot, compile them, and then eventually it gets to this great peak performance, but there is a bit of this warm-up curve in the beginning. So native image offers you a trade-off where you can take all of that overhead work, so analyzing application, compiling, optimizing, etc., and move it to build time rather than runtime, because we think that more applications are started more often than they are built. So it makes sense to do all that work once at build time, and then you don't have to do them anymore at runtime, and you don't have to compete basically with your application for the machine and machine's resources. And in the end, what you have a native executable that is specific to your operating system and your target platform, but we will get back to that in a second. Okay, and let's talk why you could be doing this. So, seems like a new programming model or maybe a new build model. So why would you be doing this in the first place? There's a number of reasons, and if you have heard anything at all about GraalVM and native image specifically, you might have heard that this is good for startup. And indeed, it's very good. So it's improving startup in matter of, I would say, orders of magnitude. So comparing to running on the JVM, your application will start much faster in a matter of milliseconds rather than seconds. And you can say, okay, I can see how this is great for microservices and serverless, definitely great for the cloud, where you're paying for the resources and for how long you're using them. But maybe I'm working on a bigger application that it's long running, so maybe I build and deploy it once, and then it runs for hours, days, weeks. I don't really deploy it that often, so what if I don't care about startup? And I agree with you, indeed, there are many apps that don't care about startup that much, but there could be other metrics that you could be caring about. One could be resources usage. So let's say you want to optimize, if possible, how much memory and CPU your application is using at runtime. And this is where native image really shines, because unlike on the JVM, we no longer compile your code at runtime. So we don't need any of that code execution infrastructure anymore at runtime. We don't need to burn CPU cycles for that, and we don't need memory for that, because we did all that work already at build time. So this is really good if you want to reduce how many resources you're using in the cloud, or maybe if you want to reduce your own infrastructure usage, or if you want just to be a good citizen, save the planet, use fewer resources, save the turtles. This is really good, so I would recommend checking out native image for that one metric. Another interesting metric, and I think we will see this in a demo, is predictable performance. So on a JVM, if you ever profile the application, you could have seen that it does warm up a bit, right? Because the JVM needs to do a lot of things to understand how the application should behave. But native image already done it. It's all machine code in the end. It's all fully optimized. So for the very first millisecond, it already is available to do what it's supposed to be doing and with high performance. And I also like how the Sprint team talks about this. So they call this instant performance. So it's available instantly, but also already at the good performance. And native image has additional security layer on top of the JVM. We will touch that later in the session. And also, if you want to have compact packaging, so if you want to have small applications that are much easier to build, deploy, and then scale, native image can also help you with that. And the last point here is that if you're starting to build a new project in 2024, and now we have a lot of support for GraalVM native image, basically from all major Java frameworks and all cloud vendors. So if you're building a new app in 2024, there is really no reason for you to not be using GraalVM. But maybe enough of talking, so let's go ahead and build our first app. Okay, all good. So let's start with the plain Spring app, the one that we are looking at here. So this is my main application class, and we have my hello controller over here. And we have a bunch of other classes for other demos, but let's just ignore that for now, and let's assume this is all our app. So as I said, GraalVM is a normal JDK, right? We can verify this by doing so. So we see our Java version, that is GraalVM for JDK 22, the latest released GraalVM version. We also released on the same day as the Java team releases JDK builds. So basically on the same day, you can get the latest of Java and GraalVM in one build. But let's run this app. So Maven Spring, if I could type boot, no, run. Okay, it starts in something like a little over 1 second. Not too bad, but also I need to be honest, this is a fairly good machine, right? And if we go here and we go to hello, we see our endpoint. So, nothing complicated so far, but we can make things more interesting, right? And we can do so by going and checking out my POM.xml. So the way I generated this project is I went to the start.spring.io and I added my Spring dependencies web and I added GraalVM. And Spring uses this native Maven plugin that is developed by the GraalVM team, and that is one kind of recommended unified interface of working with GraalVM for all the library framework authors, but also for users. So those plugins are coming from our team, and they help you build, test your applications, and configure necessary things. So let's go ahead and build it as a native app. So Maven pnative native compile. This will now start a native build, and at this point, I sometimes hear this comment from people, hey, but this compilation takes a while, I don't have that kind of, attention span, maybe you can do something about it. We can do something about it, we are working on it, but also I want to point out, so now as native image is analyzing my application, it will tell me how big my application is and what it has discovered about my application. So let's see. Performing analysis, and it's done. And you can see that my application is not that big, right? So it has a couple of classes, and it has Spring as a framework, obviously, so some dependencies. But overall, it has discovered that there is over 16K of types in my application, 25K fields, and almost 90K methods. So even for a smaller application, this is still Java and Spring Boot. There is a lot to analyze and optimize if you want to produce a self-contained native version of it. But now our build is done. And it took 44 seconds. So let's see how it actually works as a native app. First of all, let's explore what we got in the end. Target. And this is my plain demo app that we just generated right now. The time zone is slightly different because I think the instance is in a different region. But this is the one that we generated right now. And the size of my app with all the dependencies fully self-contained is 46 megabytes. So let's run this. So target demo. So if you remember, the JVM version started in 1.1 seconds, something like that. This one already started in a fraction of that, so just 47 milliseconds. And if we go to our endpoint and pretend that thing was never there and just start from scratch and do hello, it returns the same message. So this application is not doing a lot yet, but we will get there. And one more thing that I want to illustrate here is the resources usage. Let me see if I got this on this example. So let's do this. Let's do user bin time, and I want verbose, and I want to run my app. So target demo, and it's on, and now we are observing how application is behaving. So let's go ahead and let's send a couple of requests. This will not be a scientific load testing. We will do more scientific load testing later on, but this is good enough to set this to show that my application is indeed on and it's working and it's ready to serve requests no matter how many they come in. So let's say we have sent some load, and let's go ahead and kill it. So we can check out the report coming from time. And what I'm interested in is this maximum RSS. And for this app, it's at 70 megabytes. Well, 69 to be strict. So 2 observations here. I could have tuned it down further down. I did not do it. I just wanted to have like a simple demo. But I can definitely take this size further down. And even still, without any optimizations, I would say 69 megabytes is quite cool for a web application that is Spring app, fully available, ready to serve requests. So if you want to minimize your memory usage, this could be a good way to go, especially maybe for web applications and serverless applications where you see that you don't have a lot of load. Maybe you want to make them more resources efficient. Maybe you want to deploy them on a smaller cloud instance that you don't pay that much for. So let's say we have our base application and we want to keep building it out and we want to add some cool new libraries and dependencies. So how do I know that I can use library X with GraalVM, and how do I go around about adding more libraries and my dependencies to the project? So one thing to note here, so the reason why this is maybe slightly different from adding libraries to a normal Java project is that native image builds your application ahead of time. And the way it's possible to even do something ahead of time is that native image operates under a closed world assumption. So everything there is to know about your application needs to be known at build time because the runtime hasn't happened yet. And technically, with a few exceptions, there is no way of knowing what will happen at runtime. So you need to tell native image exactly what will be happening at runtime. So things like reflection, serialization, proxies, resources require additional configuration. Now, configuration does not mean necessarily that you need to produce it manually, that you need to write JSON files, because none of us like it. But that configuration could be coming from a library, framework, etc. There just has to be a way to tell native image, hey, please make this available at runtime. So the list that we are looking at, there is a page on our website called Ready for GraalVM Native Image. And that is a community-maintained list of libraries and frameworks that are known to be tested and continuously integrating and working with the GraalVM team to validate that this library is indeed working with GraalVM. So if we go to our website, graalvm.org, and if we look for that page, and I can just pick it up from my history, so you will see this long list of libraries and frameworks. I need to say that this is contributed by the community. So this is a list of known libraries. There might be more out there, but those definitely work with GraalVM without any effort at all. And to illustrate that point, I want to show you one more demo. That will be a Spring AI demo. I'm curious, how many of you have tried maybe Spring AI already? Okay, quite a few people. I was asking this question at a different conference a couple of weeks ago. It was way fewer people. Okay, so let's go ahead and let's check it out. So native Spring AI. Okay, let's see. So here is my native Spring AI, and this is my app. So this is my main application class. This is my controller. And the app itself, it will be a travel recommendation kind of service where you can say, as a user, hey, I want to travel to this destination, and I feel like doing this activity, and this is the mood that I am in. Please recommend me what I should be doing in that place. So this is our recommendation logic, and we have our service that will go ahead and talk to OpenAI, and it will produce a recommendation of where we should go and what we should do. And a fun fact, so I don't know if you've seen this GPT-4o release. That is all the hype on Twitter right now. And last night, I saw my friends tweeting about it. Oh my God, 4o is so good. It's so fast. The recommendations are so amazing. Then last night, instead of sleeping and getting ready for my session, I went and I upgraded my demo to 4.0. So we will see this new release of GPT-4 in this. Well, I'm glad that somebody appreciated it. Thanks. So let's go ahead and check it out. So yeah, we are in our Spring AI folder, and I already have it generated. We don't need to look at the native image step generation again. But just for the understanding of the size of my app, this is 111 megabytes, and this is my complete app with all the classes, all the resources, my little front end. So this is my whole application, and if I want, I can zip it down even further. But I would argue that this is still already fairly small. So let's remove this. And let's run it as my native app. So target travel app. OK, it's on. Again, started in 54 milliseconds. So if we go here, localhost. So one more thing that I would like you to appreciate here, this page might not look like a lot, but this is third or fourth iteration of the design because I'm not a front-end person. So it might not look very impressive, but for me, that was a huge accomplishment. It already looks much better than the first version of this app. So I think you can appreciate this beautiful UI. But let's test our app, and this is a travel app. So let's say we want to go to Switzerland. And as an activity, let's say we want to do hiking. I don't really want to, but this is the kind of thing that you have to do if you're going to Switzerland. And let's say we are feeling adventurous. So what will be our travel recommendation? OK, I recommend Zermatt. It's a car-free village located in the Swiss Alps and is home to the iconic Matterhorn mountain. Blah, 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 but I would suggest that this is a good suggestion from what I can tell about traveling to Switzerland. And just to make sure that this app is indeed working and there is no baked data inside, let's do something else. And let's say we want to go to Germany this time, and we don't want to do hiking anymore, so maybe we want to do, I don't know, cocktails. And let's say we are feeling risky this time. OK, so to go for Germany for cocktails, and if you're in a risky mood, I recommend visiting Berlin. So I've been to Berlin. I think this recommendation checks out. It's a capital of Germany, but also renowned for its eclectic nightlife and adventurous spirit. So I would say it's a good recommendation. And in the end, what is the cool part here is that you can use it with GraalVM. You don't need to do any configuration at all. This just works from Spring AI and our integration with the Spring project. And this is the kind of app that you can fairly easily build yourself. Now, one note about Spring AI. As far as I know, this is not GA yet, so this is still work in progress, but the team is working on it. And somebody told me that Spring AI is going GA next month, so we are almost there. It's almost readily available for us to use in production. So this is kind of cool, and this is an example of libraries that you can use with GraalVM in a native image mode and just run your applications with all the dependencies as a native app. Now, this will get a bit tricky, but I do want to mention this because this is an important part for working with libraries, and this might be a lot, but stay with me, we will go through it. So how do we go about using libraries with GraalVM native image, and what do we do about those more dynamic Java features? How do we make them happen in native image? Now, each bullet point here, it's not like all the steps that you need to take, but it's rather each bullet is a way to go around libraries and dynamic features, going from the best case scenario, low effort, down to a little bit more effort from your side. So let's talk about it. First of all, libraries can be native image friendly out of the box. So they can be written in a way that native image understands there is no problem whatsoever. And lately we see a lot of more such libraries popping up, but they're just written in a way that native image can understand. There is not a lot of reflection going on the kind of reflection that native image understands. And if there is configuration, it's maybe written in a more functional way that it's easier to process for native image. So libraries can be native image friendly out of the box, no effort from your side whatsoever. Now, if there is something that the library is doing that native image needs a bit of config for, so again, reflection, proxy, serialization, etc., the best thing the library can do is ship this config for native image within the library itself. And then again, for you as a user, it's all hidden in the underneath the library itself. It's not something you have to configure. So as an example here, I would like to show you this example from H2. In the past, I used to show a demo of H2 not working with native image, and then I make it work. But now I don't need to show it anymore, because if you look at the H2 source code, there is this file reflect config JSON. And if it's in this meta-inf native image directory, it will be discovered automatically. Native image will pick it up. This is not something you have to do. That just makes those reflection calls visible and available to native image. And it just works in native image mode, no effort needed from your side. Now, in case a library did not introduce support for GraalVM native image yet, the next best thing you can do as a user or maybe contributor is contribute those configuration files to what we call GraalVM reachability repository. And it's here on GitHub because we thought that, it could be that the library hasn't added support for GraalVM native image yet, but maybe you as a user have discovered config, let's say for, I don't know, H2 or MySQL or something. So instead of every user figuring this out by themselves, we have created a centralized place where users, authors, maintainers can contribute config for many projects. And then you can just automatically pull them from this place without any need for you to discover this configure by yourself. So if you go here, there is a lot of projects over here, and this all contains configuration for all those libraries to make them work with native image. And the best part is if you are using our native Maven plugin, such as the one that I have showed in the Spring Boot project, or if we have the same for Gradle, this will be discovered automatically. So we will say, hey, look at the project, analyze what dependencies are there, and pull config with all the dependencies from this centralized repo. And again, things will work for you out of the box. Okay, so, and I would say those first 3 bullet points, that's the happy path, but also it will be most of the cases, especially if you are starting a new project again in 2024. So those things will work for you one of those ways, no need for you to configure things manually. But what if you maybe want to move an existing, maybe slightly older project? So for example, if you have a Spring Boot app that is not on 3.0 yet, but on an older version of Spring that doesn't have GraalVM native image support yet. So what do you do about libraries there, and how do you make things such as reflection work in that case? Specifically, if you want to talk about making those things work from a framework, let's say your framework does support GraalVM native image, and it has this kind of API that lets you generate files for native image. For example, for Spring Boot, you can create those runtime hints class and talk to the Spring API to say, hey, I will need to access this app.properties file at runtime. Please generate those config files for me. And this is a programmatic way to get Spring Boot to generate config files for you. So if you're on a framework that is already GraalVM friendly and has this API for generating hints, this can be very helpful for you to say, hey, I don't want to do this manually. This is something that I would need to access at runtime. Please go ahead and generate those config files for me. This is a good way, but if you're on the older version of a framework, maybe you're not using any framework at all, maybe you have your own custom code, the next best thing you can do is that we have a tracing agent inside the native image itself. And this tracing agent exists so it can observe your application behavior at runtime. And let's say I'm making some reflection call at runtime, or I'm accessing some resources at runtime. So the way I will do this is I will run my application on the JVM. I will attach the agent to that process, and I will just do what my application is supposed to be doing, such as make that call to that resource. And the agent will observe my application behavior and output this configuration file for me and put it in the directory where native image can discover it and just pick it up at runtime. So this is, I would say, a semi-automatic way to produce configuration for native image. And then the last resort, the last way is that you can, if you know that you just have making maybe one reflection call or accessing one resource, you can just write this JSON file manually and put it into native image folder. But I kind of hope that you will never get to any of those bullet points below anyway. And I just wanted to cover all the bases. So hopefully to make libraries work, you can stay within the first 3 bullet points. And then if none of them working out for you, you can move further down. But this is a complete recipe of how you make libraries work with GraalVM. Now, let's talk about how we can further build our applications. So in terms of testing and in general developing your applications, our general recommendation is that you keep building and developing your application on the JVM. And then for native, you would compile to native maybe in your CI/CD, or let's say once a day, but you don't have to recompile the application to native all the time, because that doesn't make any sense. Our recommendation is that you develop your application on the JVM, and then you compile your application to native, either in CI/CD, or if you are introducing a new dependency and you want to make sure all the things work, or if you're attaching things that you know are sensitive to native image, so reflection, serialization, etc. But overall, you just develop your application on the JVM and you compile to native towards the end and closer to your deployment. Now, let's talk about performance, because I work on a compiler, so obviously I like talking about performance. And to illustrate performance, I want to show you an example of a Spring pipe cleaning application, because this is a bigger application and it's a bit more representative of what you will see normally in production in practice. And we tested that application under bigger load in a proper benchmarking setup, and those are our observations. So GraalVM running with the C2 JIT, and that is the JIT that you have in OpenJDK, so this is effectively your OpenJDK kind of setup. And the other combination is GraalVM native image with all the optimizations enabled, and you can see that it can be slightly faster even than the application running on the JVM. And for us, coming from the Java world, this might be a very new concept, so how can AIT code be compiled and run even faster than on the JVM, because we know that the JVM is very good at peak throughput, and it definitely is. It's very hard to beat JVM at peak throughput. But also there are things that native image has and the JVM doesn't. And that is, for example, that native image can dedicate time and resources to fully optimize your application, because it happens at build time, and we are not competing with your application at runtime. That is one thing. And also operating under closed wall assumption, we can make more aggressive optimizations because we know exactly what will happen in the application and what will not happen. So unlike the JVM, we can be very aggressive in the way we optimize the application. And the last thing is even profiling. So a very strong part of the JVM is that it can profile your application and know exactly what is happening at runtime and optimize for those parts of application. So native image can also do profiling through what is called PGO, profile guided optimizations, and it can profile application in a way even better than the JVM because it can optimize your full application. It has a view of your complete application. And with all those things combined, indeed, we can reach peak performance that is on par or slightly below or slightly above, but on par with the JVM. And another metric that we would like to talk about it, so we talk about the resources usage a lot because we think that this is important, right? So if you can run the application and get it to do whatever you need to do, but use fewer resources, this will be very helpful. And what we are looking at here is memory efficiency. So we took what is called throughput density, so operations per gigabyte per second, so how much throughput you can get per given amount of resources. And we mapped that onto our XMX settings to see if I give my application more memory, does it help memory efficiency? Does it help me be better at how much output I'm getting with my resources? And the orange line, that is native image, and the blue line, that is GraalVM with the C2 JIT. And there are two observations here. So one is that native image will give you consistently better efficiency in terms of memory than C2 because we are not compiling at runtime anymore. And B, I would say at around 512 XMX settings, maybe up to 1 gig. So I would say small, medium, heap kind of applications. It will be almost twice as efficient as the JVM, specifically for smaller and medium size heaps. So if you want to get the most for your resources, that will be the recommendation of the memory that you give to the application. But even for larger application, it will still give you more value for the resources that you have at hand. And I will not stop here, but even if you want to optimize for things like latency, that is also possible with GraalVM native image, and more specifically with the G1GC that you also have available in native image. Okay. And let's talk about some tips, tricks, and good practices that I can recommend for you for native image. So one thing I can recommend to you is, in terms of packaging, you can have very small container sizes if you're going with native image. I showed you the size of application that I had for my Spring Boot applications, but also if you want to just deploy application, and here we are looking at the JDK Simple Web Server app, and you can take the image size down to 8 megabytes even, and the blue chart, that is the running on the JVM still, so in JIT mode, and the orange one, that is running on GraalVM native image. So if you want to have smaller packaging sizes, that is definitely possible with native image. And now talking about deployments. So I mentioned that native image generates native executable specific for the platform and architecture. So if I'm using my MacBook, I cannot build a Linux image on this machine because I would need some JDK specific classes from that target platform. So to build for specific architectures and operating systems, you would need access to those machines. But there is a very good recipe for that, and that is called GitHub Actions. And we have our own GraalVM GitHub action. I can maybe super quickly show you on the example of my Spring Boot app. So I have GitHub Actions workflow set up here. So every time I'm adding some new change to my application, I see here I have build set up for macOS and for Ubuntu. So I have my app generated over here, and I can use it myself, or I can give it to my users. So if I want to have cross-platform builds, I would say CI/CD, but specifically GitHub Actions is a very good option. And specifically in the last few years, they added very good runners. So even if you want to build something bigger, such as Spring Boot application, you can definitely do it on GitHub Actions. Okay, and one more thing that is specific for Spring projects, because they endorse Packetable build packs a lot, but also you can use this outside of the Spring world as well. You can use Oracle GraalVM inside your Packetable build packs build, and this way you can generate container images that will be running on Oracle GraalVM and on native image. And a few words about security. So native image adds this additional interesting security dimension to run your application on the JVM, and that is coming from a few properties of native image. So one thing I mentioned, that native image eliminates all the code that you're not actually using. So the things that you will not use, native image will just throw out and not put in this produced native executable. So this way we are reducing the attack surface because there is less to attack, less surface exposed to the outside world. And things as reflection, serialization, etc., as we mentioned, require an additional allowed list from your side. And this might be seen as a limitation in a way, but I think it's just a different maybe programming or deployment model where you have more control and more awareness over what is happening in your application, because those things need to be configured either by you or library or framework. And last but not least, there are some attack vectors that target the JIT compiler specifically. So those are simply not available in native image because at runtime there is no JIT compiler, nothing anymore. it is all ahead of time compiled. So it does add additional a security level on top of the JVM. Okay, and if you want to take one slide, one photo from my presentation, I would recommend that this will be a photo of this slide. So those are my recommendations if you want to move to GraalVM, maybe for your existing project, or maybe you want to create a new project. Those are the things that I would recommend. So the first step is add native build tools. Those are our Maven and Gradle plugins, and that's one standard interface that will help you build and deploy your application. And also those are the tools that will pull config for node libraries from the GitHub repo. Now, for deployment, keep building on the JVM and then compile to native image closer to deployment. You don't need to do it all the time. And I know that build times can be longer for bigger applications. So one thing that I can recommend there is this -OB flag, and that is quick build mode. It will not be like 5 times faster, but it will be maybe 20% faster. And this is a development tool. Don't use it in production. But as you are still building your application, this is very helpful to have faster build, so you have faster kind of response cycle from native image. For deploying, please use CI/CD systems. And then to optimize your application, the best thing you can do PGO, and that is you can collect profile information of your application by building an instrumented version of your native executable, running it with relevant workloads, and then you can get a profile file out of it. And then you can feed this file back into native image, so you can build an application that is aware of the runtime behavior, so that is aware of what will happen in runtime, and we can know where it makes sense to invest our compilation efforts. So you can combine like ahead-of-time compilation with the power of profile-guided optimizations. Now, we understand that it's not always available. Then you can collect your profiles because it requires 2 steps, so like instrumented run and actual production optimized run. And the best thing we can do is we can use an ML model, and we have a little ML model inside native image as well. So if you don't give us any profiles, we will use this ML model to look at your application and analyze and try to predict what will become hot at runtime. And then we will optimize based on those predictions and those profiles. So if you are using Oracle GraalVM, this is enabled by default. And another thing for performance, there could be different GC strategies, but if you want to optimize for peak throughput, I would recommend that you try out Java GC. In my observation, it always looks the best in terms of peak throughput. And the last flag is MARC native. So if I know that I will be running my application on this target machine, I can tell native image, hey, please use the specific hardware features of this machine and optimize to make the most out of this hardware. Okay, what's next for GraalVM? And let me check the time and see if I can do one more demo. I think I can. So the latest release is GraalVM for JDK 22. We always release on the same day as the Java team, so you can get the latest builds at the same time. And let me see if I can super quickly show you some performance demo in action. For that, let me go back to our first native Spring app, native Spring Boot. Okay, let's see. And I have my little benchmarking setup over here. So first, we will run this application on the JVM, and I'm turning off GraalVM as a JIT compiler. So effectively, I will have C2, meaning I will have OpenJDK. And I will use PS record to produce the chart of how my application behaves at runtime. And then I will do benchmarking, and I send load using the tool called Hey. I love Hey, and I can highly encourage you to use it for load testing. And we will send 500,000 requests, so 2 batches of 250,000. So one will be kind of warm-up run, and the second one will be benchmark run. And then we will compare the results. So this is not the most scientific benchmarking setup, but scientific enough for a conference session, I think. So let's first run this on JIT. Bench JIT. And actually, we're also starting our application, and we are waiting 2 seconds to give the JVM time to actually start up before we are doing even the warm-up run. So this is not like entirely scientific, but scientific enough, I would say. So this run is done. Let's see at the results. Let's look at the results. So for our warm-up run, throughput is 45K, well, roughly maybe 46K per second. And latency for most of our responses are within 10 milliseconds. So this is the warm-up run. And the actual benchmark run, we see that it got better. So it's at 52K. And response times are, OK, this is surprisingly fast, I would say. I don't really buy it, but OK, fast enough. So let's run the same thing on native image. So let's get ourselves another tab, and let's do bench native. And let me check what are my memory settings, because I was playing around with that. But no, the memory is the same. OK, so we can run it. OK, so who thinks native image will be faster than the JVM? Raise your hands. Okay, some people, but not many. But like I'm advocating for GraalVM, so I could have made some tricks and magic to make it look faster than JVM, right? But let's see. Okay, it's all done. So just to recap, the JVM had peak throughput of 46K in the warm-up run, and then it warmed up to 54, I think. Yeah, 52. And now the native version is at, where is it? This is the warm-up run. So this is at 50K. So no warm-up, it's already available at 50K requests per second. And then the actual benchmarking run is, okay, it did get a tiny bit slower, but I think you can agree that this is on par with the JVM. So you can always hear that, GraalVM is great for fast startup. It's like smaller images, but they are not very fast. There are no way that as fast as JVM. You can see that that is not true. But I can do even more cool thing. So this is my native benchmarking setup, and I can go here, and I can take this down to basically half, which kind of looks like abusing the app, but honestly, I can go even much lower. So let's run this now again, and now this will use just half of the memory that I had before and half of the memory that the JVM had. So exactly 1/2, but let's see how our application will behave now. Okay, executing benchmark load. Okay, all done. Let's see. So the JVM, the warm-up version was at 52K, and the benchmark run, and the warm-up was at 46. Now our native image with just half of the memory is still at around 49K requests per second, and same for the warm-up run. So it got like slightly lower, but still on par with the JVM. And I have personally 2 observations here. One is native image can have comparable throughput with the JVM, even at half of the memory that we give to the JVM. And I can turn it down even further. I just will not do it now. Or even better yet, what I can do is I can deploy 2 instances of my native application at the memory footprint of just one Java application. And this way, effectively, I can have double the throughput of the JVM for the same memory footprint that the JVM was having. So this is pretty cool, I think, and this is how you can reduce resources usage of native image. Okay, I see I have 2 minutes left, so I want to talk about 2 big flagship projects that we are working on and what is coming next for the GraalVM world. So one is called layered native images, and that is one of the biggest projects that we are working now. So I mentioned before that if you have a bigger app, it can take maybe a few minutes for native image to compile it because there is a lot of work to do at the build time. We understand that, and we are working on a better way to do it. And the better way will be that, let's say I have my application that is maybe, again, a Spring Boot application. So what I can do, I can compile what we call JDK base, and I can use it basically as a shared library. And I can compile my Spring components, so maybe my Spring Base, my Spring Web, again, as shared libraries. And then as I'm developing my application, I will only compile my user code, so the code that I actually wrote, and the rest stays compiled. So this way, we can take compilation times down to a matter of seconds because I will only recompile this application code fraction of it. It will be great for developer experience because you will have much faster build times. But another big benefit will be when you're deploying your application, you can, let's say, deploy 5 instances of my Spring app, and then they will be reusing the same JDK base, the same Spring base, and this way you can have resources sharing in the cloud. So again, you can use even fewer resources in the cloud with layered native images. This is a big project. It will take us a while to get working, but we are working on it, so hopefully we'll share more results with you soon. And another even more ambitious project that we are working on is called GraalOS. And this will be, well, not an operating system, but a development platform that will give you a way to deploy your applications as native images, not containers, because we want to eliminate the complexity, but also we want to give you a better way to deploy applications even with less startup and eliminate all of that startup coming from container deployments. So again, working on this will be available soon. So with that, those were the benefits of GraalVM native image. I hope I convinced you to try out GraalVM native image either for startup or lower resources usage or for great performance that is on par with the JVM. And to get started with GraalVM, maybe you want to take one more photo. So this is the website where you can find all things GraalVM. You can pull our container images, or if you're using SDK-man, as you should, you can pull our latest images always from SDK-man. With that, that is all that I had. If you want to stay in touch, here are a few links. And if you have any questions, I'm afraid I might be running out of time, but maybe you can come and talk to me here. And I also should have some stickers with me. So Dankeschön, and please come talk to me. Thank you.
We've got 3 questions. If you want to answer them, you got 5 minutes.
I don't know if people want to still hear the answers, but I can super quickly answer as you're getting ready. So in a large app, and while library is not native friendly, can I still compile the app natively? Yes, you can produce config with that library yourself, and it's fairly easy with a tracing agent. So I would recommend that that's a good way to go. You just run your application on the JVM, produce the config, and it gets picked up by the native image. Can I build native images of desktop applications? Oh, sorry, your app has locked. I think it was like AWT, Swing, etc. Depends on the platform. On Linux and in Windows, it's easier. It is still coming to Mac OS. Is there a Gradle plugin or something like that? Definitely there is a native Gradle plugin from our team. You can just find it on our website. Thanks. And if you have more questions, please come here. Thank you.